Let's take a look at this phone. Hello, my cute American chubby baby fans. This is an iPhone 13. Upon starting it up, we find the phone has no power left. We plug in the charger. After charging for a while, the phone has started up. This indicates the phone can boot up normally. Let's enter the owner's password. First, let's use the quick settings menu to check. Wi-Fi and Bluetooth can't be turned on. They are grayed out. And the Wi-Fi button in settings is also grayed out, unable to be enabled. Bluetooth is stuck spinning, unusable. Let's go to General and look in about this phone. This is a 256 gigabytes Chinese version iPhone 13. Scrolling down, we find the Wi-Fi address. It says not available. The modem firmware version is present. Let's go to the dialer interface. Enter *#06# and the IMEI code pops up. This indicates the baseband is also working normally, so the actual test confirms no Wi-Fi, no Bluetooth, and the baseband is intermittently available. Furthermore, the phone also has a fast battery drain issue. Apple phones have more and more features and are getting faster and faster, but in terms of durability, why are current iPhones like the 13, 14, 15 less drop resistant than the old iPhone 4 and 4S? So, from the Apple iPhone 4 to the current iPhone 17, which model do you think is the most drop resistant? Today, with these questions and while repairing this phone, we will analyze it in detail. Give me a like. Opening the screen, this phone is confirmed to be opened for the first time. We protect the front-facing Face ID assembly. The first step is still to disconnect the battery. The iPhone 12 has two separate cables for display and touch, while the iPhone 13 integrates them into one cable. Removing the screen, we can see the battery has slight wrinkles around the edges. This indicates the phone was heavily dropped. The no Wi-Fi and no Bluetooth issues are caused by the logic board. So we need to remove the logic board, disconnect all the cables connecting to the logic board, remove the screws securing the logic board, and then take it out. There's a hidden screw here. After taking out the logic board, we need to inspect it. Since it's a heavily dropped device, we check the board for any cracks or deformation, especially at the corners. Very lucky, the owner's board shows no signs of deformation or cracking. However, since the iPhone 13 also uses a stacked logic board, and the parts responsible for Wi-Fi, Bluetooth, and signals are on the lower board, we need to separate the upper and lower boards to find the source of the problem. We place the board on the heating plate to heat it up. Gently test if the solder balls between the layers have melted. Once all the solder balls between the layers have melted, we can separate the upper and lower layers. After separation, let's examine both the upper and lower layers. First, check the connection points for any missing solder balls. The upper layer looks fine. All points seem normal, but the lower layer is different. We can see this area of points is black, a different color from the normal solder points nearby. The corresponding points on the upper layer are bright white, only slightly darkened. After separating the layers, we continue to examine the lower layer, as its substrate is also prone to cracking. If there is any cracking, deformation, or depression, we would need to transplant the Wi-Fi and baseband chips to a new, good substrate. Because these two chips are encrypted and paired to this specific phone, let's look at the blackened points on the lower layer, these points here. Each one is basically connected to the Wi-Fi chip. A few individual points connect to the baseband. This confirms that if these points are poorly soldered or faulty, it causes no Wi-Fi and no baseband. Because the CPU cannot detect the Wi-Fi and baseband chips, let's measure again. Check if the upper layer alone has any current leakage. After measurement, the upper layer alone shows no leakage. The starting current is normal after checking the upper layer. We need to check the lower layer. Under the microscope, let's observe the lower layer. The lower layer mainly contains the Wi-Fi, baseband, RF, and power amplifiers, basically all related to signals. The appearance shows no suspicious issues. We also need to measure all the power supply circuits around the Wi-Fi and baseband chips. Check for any abnormalities. Okay, all the circuits on the lower layer are normal, no abnormalities. Back under the microscope, we continue observing these blackened points. Why are they black? It's very clear this phone was heavily dropped, and stress was concentrated in this area, causing poor solder connection and blackening. Sometimes oxidation also causes it. After blackening, the solder points cannot work properly or conduct electricity, so the CPU cannot detect the lower layer's Wi-Fi or baseband chips. In settings about, there will be no baseband and no Wi-Fi. Unable to make calls, unable to use wireless networks. Fixing this requires scraping off the oxidized coating on these blackened points. After scraping, the solder underneath should appear bright, so it can conduct electricity properly. Note, the force must be just right. Too much force can scrape the point off. Too little force won't scrape it clean. So, first we scrape roughly, then clean it, then scrape more meticulously, clean again, and scrape once more. Now we see these points have changed from black to bright. Apply flux to the solder points on the lower layer. First, apply solder balls to the previously blackened section, then reflow solder over all the other points. Use solder wick to flatten the points. Finally, clean all the points. Observe the solder points on the lower layer. The lower layer is done. Now we process the upper layer. Similarly, apply flux to the upper layer's connection points, then flatten each solder point as well. Clean the upper layer's solder points. We take the soldering stencil and apply solder to the lower board's points. This facilitates soldering the layers together. Then melt the solder balls. After all points are processed, we place the lower board on the heating plate, apply flux. Apply thermal paste on the upper layer's A15 CPU, then align and join the upper and lower layers. When the solder balls between the layers melt, poking them slightly gives a rebounding feeling, meaning all solder points have melted and the soldering is complete. Then let the board cool down. Clean the board thoroughly. Now we need to power on the board. Press the power button to see if there's any leakage or any abnormal boot behavior. Okay, after joining the layers, the phone shows no leakage current. We reattach all the shielding and stickers. Let's continue our discussion. Actually, the iPhone 4S isn't the most drop-resistant phone, because the iPhone 4S back is also glass, and it's very square. When dropped, it might absorb some impact force. Actually, starting from the iPhone 6, which adopted a curved edge design, the drop resistance became better than the iPhone 4S. Now, since the iPhone 10, all models use a stacked logic board design. This is also to free up more space for the battery or other components, resulting in stacked boards that are prone to issues like in this video when dropped. However, the device in this video is a relatively mild case. Severe cases require transferring the upper layer to a new lower layer for possible repair. But starting from iPhone 14 and 15, the stacked board design has also been improved, largely avoiding connection issues between board layers caused by light drops. So, everyone take a guess. Will this year's iPhone 17 series still use a stacked logic board? But no matter how it's designed or updated, it will have its common issues. Humans can't be 100% perfect, let alone a phone. What we need to do is maintain a normal mindset. Try to avoid dropping the phone heavily, and let it accompany us for a few more years. After closing the screen, we place the phone in the sealing press tool for pressure. After successful sealing, take out the phone. Install the two bottom screws. Then we use this data cable that can show charging current to power on the phone. After booting, we enter the owner's password. First, let's check Wi-Fi. Okay, Wi-Fi shows not connected, but the button can be turned on and it can search for networks normally. Bluetooth can also be turned on normally. Wi-Fi and Bluetooth share the same chip. We need to test all other functions. And about this phone, the Wi-Fi address is now present. Asterisk hashtag 06 hashtag pops up the IMEI, indicating the baseband is also working normally. Let's test the camera, flash, and Face ID. Okay, all functions are completely normal, but for this kind of repair, we need to test it for several more days. Because the lower layer was heavily dropped, there are many uncertainties. Grateful thanks to every fan for your support of Big Brother. If you like Big Brother, double tap the screen. If you haven't followed yet, please follow.